Today we're doing section 8.4. We are going to use properties of logarithms. So those same logs that we've been working with, starting with section 8.3. Today we're going to learn a little bit more about them. To warm up, we've got a couple log problems. Now, what I was telling you before was that you've seen problems that's like one piece of this at a time. So you should be able to handle log base 2 of 4 and evaluate what that is. If that was the only part of the problem we were worried about, what do we set it equal to?
4.
X. That's how we figure out what it is. We change it to exponential form. So what's my base?
4.
2. Same base that the log has. My exponent is x, and it equals 4. So this one comes out to be x equals 2. So that means this whole first log equals 2. Plus, now we're going to switch over and look at the other log. So if we were to solve just that log base 2 of 8 equals x, because we don't know what it is. That's why we set it equal to x. My base, 2. My exponent equals, so x equals 3. So as Charles was asking, yes, the last step is just to do whatever they told you to do with those two numbers. So 2 plus 3 is 5. So 5 is the final answer to that whole problem. Questions, concerns? All right, on number 2, it's a little bit different. We've got a different base, same idea. Now, if you need to rewrite log base 3 of 9 equals x to be able to see how to rearrange it, that's fine. If you can kind of go straight to exponential form, that's also fine. What's my base? 3. My exponent, it equals 9. My x equals 2. 3 squared is 9. So that one's a 2. Put a minus sign in between them. Now I have to evaluate the other part of it. So log base 3 of 27 equals x. If you want to use a different variable on the other part, that's fine. It doesn't matter what variable you use. We still don't know what it is. My base is 3. My exponent, it equals, well, okay, for right now it equals 27. And then when we go to solve for x, what do we get? What do we get?
3.
X equals 3. Okay, some people were jumping ahead on that one. And yes, 2 minus 3 does equal -1. So overall, that evaluates to -1. Questions? Concerns? We're sure. Properties of logs exist that can be used to simplify these problems into a single problem. That is probably not how I would have worded that, but that's fine. So there are properties that we can use to simplify those problems that we just did, as well as some other problems. So the product property states that if you are taking the log from some base to a product, two things being multiplied together, that you can split that up into two separate logs being added together using the same base as before, but splitting the factors up. And you can use this property forwards or backwards, which means that first warm-up that we did, we could have changed it and written it as a single logarithm. See how on the first problem it's 2 logs added together? That warm-up number 1. We could have rewritten it and multiplied that 4 and 8 together to create a single log. If you don't see that right now, we'll do more examples with it soon. Similar thing for the quotient property. The the log of a quotient or fraction or division problem can be split up into two logs. Log of the numerator minus log of the denominator. Again, it can work the other way. You can take a subtraction problem of logs with the same base and rewrite it as a single log using division. Last one, the power property, was always kind of my favorite one. I'm not really sure why, but it just was. So the last one was always my favorite. If you're taking the log of something that has an exponent, instead of applying that exponent to whatever it is you're taking the log of, you can pull that exponent out in front of the whole problem and multiply it to the log, and it ends up equaling the same thing. That last property is a little strange, but it's kind of my favorite one. So notice that exponent, they pulled it out in front of the log and multiplied it to the log instead. Now, like with anything, all of these, you'll probably catch on to them as we do examples with them. You can use more than one property in a single problem. It is possible. So for now, they just want us to state which property or properties, if there were more than one, that we used to rewrite these. So on the first one, which property did they use to rewrite a subtraction problem as a single log using a fraction? The quotient. Quotient property allows us to do that. Now, where did they go, or what did they do from the middle to the very end? It's not really one of our properties, but what happened? They simplified it, or they actually did the division. 8 divided by 4 is 2. So that's not really a property we have to state, but it is something that makes these problems nice. We're able to simplify them. On number 2, what property did they illustrate? The power property. They took that exponent and they plopped it out in front of the log. They didn't put a multiplication symbol there, but we kind of assume it when it's written out in front, that there's a little time symbol in there. So that was the power property. And on the last one, they rewrote an addition problem. So what do you think that they used? The product property. Now it doesn't really look like it, but if we were to multiply 16 times 32, guess what we get? 512. Okay, so 16 times 32 does equal 512. So that is the product property. So on these ones, we are going to use the properties so that we can express this with a single log. So notice on number 4, we've got 2 logs. They have the same base. That's important. We cannot use these properties unless it has the same base. Which property do you think we're going to use here? Quotient. We can rewrite a subtraction problem as a single log using the quotient property. So what's my base going to be? 3. The base does not change. And if I'm using the quotient property, I'm going to take what divided by what? 20 divided by 4. Now I know many of you know what that is just by looking at it. I would recommend writing that step initially so that when you look back at it, you know what you did to get to your answer. But 20 divided by 4 is 5. Notice how I'm writing my base a little bit lower and a little bit smaller than I write the number that goes next to the log. You should be doing the same thing. If when I look at your answer, it looks like you wrote log 35, you're going to get points off. Okay. Should have best practices when it comes to expressing our answers. On number 5, can we combine these? Yeah. They have the same base. We're adding two logs with the same base, so Charles suggested that we multiply. When we say that, what are we multiplying? The x and the y. My base stays the same, so I still have a base of 2. But I'm multiplying x times y. If you want to put a multiplication dot in there, or you want to use parentheses, you can. But you do not need to.
Is this a product or a power?
5 or 6?
Product?
5 would be product. We're multiplying. On number 6, which property do you think we can use? Power. Now, it's already written as a single log, but if we're practicing our rules, this coefficient out in front of the log can become what? The exponent on x. So we can plop it over there so that this is log x to the 5th. What is our base on this one?
10.
A 10. Remember, if it's not written, the base is 10. You still don't have to write it. I just want to make sure that we're remembering that. All right, on number 7, we are going to use two properties, and we have to be careful what order we use them in. What property or what part of this do you think we need to deal with first? Product will come second. Power has to come first. Okay, so be careful. Make sure there's nothing out in front of your logs before you start trying to use power or quotient. So if we're using the power property, what happens? We have to put the 6 where? Up top on the x because it becomes a exponent or power. So this changes to log base 5 of x to the 6th plus, are we changing anything about the back log right now?
No.
Nope, stays the same, log base 5 of y, but now we can use which property?
Product.
The product property. So we can rewrite it as a single log, same base, and then what happens? Multiply what? The x to the 6th times y. Now the reason that we have to do the power property first is because we only are giving that to the x. If you were to try to do the product property first, you might accidentally give it to the y or give it to both the x and the y, but that's not the case. The 6 that was out here as a coefficient is only going to go as an exponent on the x, not on both. Does that make sense? I see. So I hear some people saying, how are we supposed to do number 8? Why are people asking how are we supposed to do that? The bases are not the same. If the bases are not the same, we cannot apply those properties. So next to this one, I would just write bases not the same.
B and X.
No. Okay, bases are not the same. Now that doesn't mean we'll never learn how to handle that, but that means as far as the properties that we've learned just now, right now, we can't do it. Okay, so that was like a curveball thrown in there to make sure you're paying attention, which it sounds like most of us are. Good job. Now, number 9. There's a lot going on there. What do you think we need to deal with first?
The exponent on the first one.
Okay, so the coefficient on the first one needs to become an exponent. It needs to be order of business number 1, which I hope that makes a little bit of sense, because if you think about your order of operations, what's one of the first things we deal with? Exponents. Okay, and coefficients in front of logs become exponents on those numbers. So this becomes log 2 cubed. You know what? I'm going to erase kind of what's below it so that I can show all my steps. My handwriting's just a little too big for this little space. Okay, so this can become log 2 cubed. What is 2 cubed? 8. Okay, so I'm then just going to rewrite it as log of 8 plus log of 4 minus log of 16. I need to start writing my L's like cursive or curly. Okay. Now, what do you think we're going to do next?
Add it, or multiply the 8 and 4.
Okay, why would we deal with this addition before we deal with that subtraction?
Addition comes first.
Addition doesn't necessarily come first. We work addition from and subtraction from left to right. Okay, so addition and subtraction are kind of ranked the same, but we have to go left to right. Going from left to right, we come across the addition first. So this would become log of, what do we do with that 8 and 4? We multiply them. 8 times 4, so this becomes log of 32. We're still subtracting which log? 16. When we are subtracting two logs of the same base, how can we condense them? By dividing. So this is log of what divided by what? 32 divided by 16, which would equal log of 2.
What if you make? Well, how come it's not -2? Because you subtract.
So when we condense a log subtraction problem, it just turns it into a division problem. It doesn't change the sign on either of our numbers. So we just take that 32 divided by that 16. All the subtraction sign means to us is that we are allowed to apply the quotient property. So that's what we do. And log of 2 is written as a single logarithm, so we are happy with that. How did we know that all those logs have the same base? There wasn't a base written on any of them, which means all of their bases were 10. Good. Okay, any other questions about 9 before I bring back 10? We're sure? Because 9 has to go away for 10 to reappear.
Wait, what were they? What were the product quotient?
The properties?
Yeah.
We used all 3 of them. So the first one we used was the power property. That's how we got the 3 to become an exponent on the 2 at the very beginning. After that, we had to work from left to right. So we started with addition of 2 logs, which is the product property. Finally, we were left with subtraction of 2 logs, which meant we could use the quotient property. All right. On number 10, are we going to be able to condense these into 1 log?
Yes.
Yes, we can, because they have the same base. Which property or properties are we going to use? Quotient, for sure. Do we think we need any others? No, I don't think so either. We've just got subtraction going on. So I would rewrite this as log with what base? 2, same base. And I'm taking what divided by what? 9 divided by 3. 9 divided by 3 is 3. So even though this isn't really a property, I can simplify it. So we end up with log base 2 of 3. That's it. That one's super quick. No, they just said write it as a single logarithm. So we won't worry about trying to come up with what it equals at the moment. We ready for the next one? Okay, let me bring it back. Number 11. What property or properties do we need to use?
Product.
Product and power. Which one should come first? Power, good.
2.
So if we're using the power rule, the 2 that was a coefficient on a log goes where?
2 to the power. 4.
A power on the 4, an exponent on the 4. So this changes to be log base 5 of 4 squared, which, yes, is 16. So log base 5 of 16 plus log base 5 of 3. All right. Now we can also use the product property, which means we are going to do what to write this as a single log? Not add.
No,
We're going to multiply. Product means multiply. So we're multiplying what times what?
16 times 3.
16 times 3. What is 16 times 3?
48.
48. So this is log base 5 of 48. All right, write it as a single logarithm. The first thing that I can do is apply which property? The power property. And how many places can I apply that property?
2.
2 places. So this one's a little bit different. So what's going to happen?
The 5 is going on top of 2.
Okay, this 5 becomes a power on that 2.
Base is 10.
This 2 becomes a power on that 2. Yes, the bases of these are 10, which allows us to apply these rules. So we've got log of 2 to the 5th power minus log of 2 squared. Now, if you want to go ahead and apply those powers and multiply it all out, you can. But you don't necessarily have to do that right away. It's kind of up to you. If you want, you can go ahead and multiply it out, though. So 2 to the 5th would be what? 30 what? 32. So we would have log of 32 minus log of 4. Now which property should we apply? Division or quotient. So this becomes log of 8. How'd you get 8? Divide what?
32 divided by 4.
32 divided by 4. So yes, in the very end, this becomes log base 10 of 8. We're using that quotient property. Where should we use it first?
3 minus 4.
Why?
Because it has parentheses on it.
Good. We still follow our order of operations. We haven't lost our minds or anything here. So if something's in parentheses, that's what we focus on first. So log base 3 minus, or sorry, not base 3, log of 3 minus log of 4. We can use that quotient property to rewrite it as log of 3 over 4. And then we're still subtracting log of 2. So now what happens?
You guys subtract the 2.
You divide.
So we divide again. Subtracting 2 logs, if we want to rewrite it as a single, we have to divide. So that means that we are going to be taking what divided by what?
34.
Divided by 2.
Okay, so let's think about this for a moment here. 3/4 divided by 2. Now some of you might just use your calculator because that's a nice tool to have. But back in, let's say, 5th grade or 6th grade, whenever it was that you first started really learning about fractions a whole lot, did you ever divide a fraction by another number?
No.
No. What did you do instead?
Multiply.
Multiplied by the reciprocal. So we should really be taking 3/4 times,
2 over 1.
no,
1/2.
1/2. The reciprocal of 2 would be 1 over 2. Okay, so this is going to become log of what?
Negative 1 over 4.
Disagree.
That's
3 over 4 times 1 over 2. How do we multiply fractions?
Multiply across.
Multiply across. 3 times 1 is 4 times 2 is 8. So it should become the log of 3/8. All right, on to 14. Which property should we apply first?
The addition.
No.
Oh, you should, power.
Power. We got to deal with powers first. So where do we apply the power property?
Log of 2, log 2.
Okay, so 2 times log of 2. This 2 that was out in front goes where?
In front of the other 2.
Not in front of. As an exponent or power on that other 2. So we still have log of 6 plus log of 2 to the second power is 4 minus log of 3. Okay, next thing we should do.
Add.
So we want to deal with the addition. That doesn't mean we actually add. It means we're going to change it to be the product property. So it becomes log of what? If you tell me 10, I'm going to cry. 24. Okay, when we are changing an addition problem, we use multiplication. So 6 times 4 is 24 minus log of 3. Last property we can apply. Division or quotient. So this is going to become log of 8. 24 divided by 3 is 8. We're getting the hang of these rules?
Yes.
A little bit. Okay, we got one more of this type of problem. And then we're going to start doing things in the other order, the bottom of the page. All right, what property should I apply first? Power again. Where does that happening?
2 and 6.
Okay, the 2 to the 6. Now, a lot of the times, especially in Algebra 1, we would have treated this like a negative 2. Don't do that. Leave the subtraction sign there. Just take that coefficient as the exponent. Does that make sense?
Yes.
Okay, because if you take that sign away, then you have to replace it. It just gets messy. So just leave the subtraction sign where it is. So now we have log of 8 minus log of 36 plus log of 3. What should we deal with next? Ooh, we don't agree.
I mean, quotient.
Okay, quotient. Why?
Because it's
First thing from left to right. Okay, so addition and subtraction are ranked the same. We go left to right. This is what we're dealing with. So this is going to become log of what in the front? 8 over 36. Can we reduce that? 4 over 9. 2 over 9. Yes, that sounds better. Divide by 4. We get 2 over 9. So it was 8 over 36 if you need to see that. 8 over 36 reduces to be 2 over 9. That's how we got that. Then we're still adding what? The log of 3. Which means that now we can multiply. We don't have to use the reciprocal because we were not dividing with fractions. We're just straight multiplying. Addition tells us to multiply these if we're going to combine those logs. So, what are we multiplying together?
2 over 9 plus 3.
Okay, so I'm going to write that over here. 2 over 9 times 3. If I wanted to turn the 3 into a fraction, it would be 3 over 1.
So
29 over 9.
6
So I
2 over 3.
agree with 2 over 3 most. So 2 times 3 is 6. 9 times 1 is 9. So 6 over 9 reduces to be 2 over 3. So final answer should be log of 2 over 3. All right, when we expand, that means we're trying to rewrite it longer or bigger. If you see condense, you're trying to make it smaller. Expand, you're trying to make it bigger. Expand means that we're making it bigger. Condense would be making it smaller. So when we expand it, which property does it look like we're going to use first? Quotient. It should be really easy to identify here because it's written like a division problem. So quotient rule or property allows us to split it up into what kind of problem? A subtraction problem. So I'm going to be subtracting 2 logs, keeping the same base from the beginning. The log of the first one would be log of x, or your numerator, and the second one would be y, or your denominator. On 17, which property are we using? Product, which allows us to split this into what type of problem?
Multiplication.
It is multiplication, so we're splitting it into addition. Log of what and log of what? M and N. Using that same base from the beginning. All right, on the next one, we've got 2 properties that we can use. Now remember, we're working backwards, which means that our rules kind of work backwards. So be careful when you decide what you want to do first here. What do you think we need to apply first? Which property?
The power. No. The addition.
We're working backwards. So normally power property was where we went first. Now it's going to have to be last. Does that make sense? Going backwards. So if it's not going to be the power property first, which one's it going to be? Addition, or the product property. So we'll split it into an addition problem. What am I adding? Log of what and log of what? Log of 3 and r to the 4th. Are we okay with splitting that? Okay, now which property could we also apply? The power one. Okay, so now we've got a power in one of our logs. Where can I take that exponent and move it to? Which log? The second one. Okay, so it does not belong to the log that has the 3. That's why we had to wait to do it. It's only going to belong to the log of r. So log of 3 plus 4 log of r. What is the base on that one? 10. Okay, so we didn't have to write our base. Questions about it? Concerns, confusion? Warm, fuzzy feelings?
Yes.
All right, on 19, which property can we use?
Multiplication.
The product property, yes. So we are going to split this into what type of problem? Addition. Log base 2 of 7 plus log base 2 of b. Questions, concerns? Any other rules we could apply there? Nope. That means we have to move on. We're getting to the end here. Slowly but surely. Now, 20 is interesting. Okay, it's got a power and it's got a quotient. So we kind of have to decide how we're going to deal with this. What does the power belong to?
The y.
Just the y?
Y 3.
The y and the 3. So there are a couple ways to deal with this. I think the clearest way is to write it out as what the 2 belongs to first. This is not the only way to do it, but I believe that this way makes it most clear how to approach it. So I personally would give that power to everything it belongs to, which would be the y and the 3. Does it make sense why it goes to both of them?
Yes.
Okay, it was in parentheses together. Then I would start splitting it up, which people were saying deal with the quotient first, which I agree with as long as we don't have parentheses holding it together. So now we could deal with the quotient first, so we would have log of what? Y squared minus log of 3 squared. If you want to evaluate the 3 squared, you could. What is 3 squared? 9. Does that make sense?
Yes.
Okay.
You take the 2 and put it in front.
Now we would apply our power property and take that exponent and move it out into the front. So we would end up with 2 log y minus log 9. So now that 9 no longer has an exponent that we have to move. Okay, and it makes more sense for us to write log of 9 as opposed to 2 log of 3. Okay, we had to move the 2 here because we cannot evaluate y squared. We don't know what y is. Like I said, that's not the only way to approach that problem, but that is the way that I would suggest to make sure you get to the best answer. Questions about 20? All right, on 21, what property should we apply first?
No,
Product. Here, we can't really apply the power rule first because how many powers do we have? 2, and they're on different variables, and that just gets weird. So we need to first split that product up. So log base 7 of a to the 3rd power plus log base 7 of b to the 4th. Now on this one, we cannot evaluate either of those exponents. So what happens with both of them? They both go to the front of their own log. So we have 3 log 7 base 7 of a plus 4 log base 7 of b. All right, 22. This one's a little different. What do you think we're going to do? We're going to have 3 different logs, and they're all going to be added together. So we're just multiplying a bunch of stuff, so we change it into adding a bunch of stuff. Log of
X
plus
log Y.
plus. That's it. Made it as big as we could. Questions, concerns? Okay. On this last one, what rule do we use first? Product first. What other rule would come in there? Power. Let's see if we can go straight to our answer. Does anybody think they know what it is? Cydia?
Log 6 plus log 3 plus log y.
Very close.
Plus 3 log x.
Good. Okay, so in the middle we should have 3 log x and then the plus log y. Beautiful. So if you wrote it in 2 steps, that's fine. If you had to write it as x cubed and then on your last row you had 3 log x, that's just fine. Questions before I continue on?
No.
Almost done. 2 left.
Everything is different than ours. You're 24.
Oh, my 24 is different?
Yes.
We can change mine to match yours.
I already have things.
Log x4 or x to the 4th power and then
Jacob, did you say you already have it?
Yep.
What is it?
4 log x plus 2 log z.
4 log x plus 2 log z. Good. If you are getting comfortable with these rules and you pull your exponents out as coefficients, right away, I'm okay with that. But if you're even the littlest bit unsure, just do it one step at a time. Okay? Anybody get that last one?
Yeah.
Charles, what'd you get?
Log 4x minus log 4y.
Log base 4 of x minus log base 4 of y. How are we feeling about these rules?
Great.
It sounds like at least 5 of you are doing just fine with them. The rest of you, I really have no idea what's going on in your brains, so we'll work on that tomorrow. Your homework is on page 449, 3 through 39 odds. Just the odds.